Hello. Hello. Yeah, good morning, good afternoon, everybody. So, first of all, you had enjoyed your holidays in much, had an exams, and I think you must have done it great. So, first of all, just let me know if my voice is audible to you and my video is visible to you or not. Yeah, please respond. All right. So, that means I am visible to you and my voice is also audible to you. So today is the last session for indefinite integration, and we shall be discussing few more questions on indefinite. All right. And then we will jump to definite integration next lecture onwards. All right. So let's begin. So now let's begin. First question is integration 1 plus under root of 10x into 1 plus 10 square x upon 2 10x dx. Yeah, quickly give it a shot. Give it a try, then we will talk about it. All right. See, this question I'll do for you. The very obvious substitution here is the question can be written as 1 plus under root of 10x. 1 plus 10 square x is secant square x upon 2 tan x dx. Now, if you assume tan x as t, then secant square x dx will be dt. Am I correct? If I assume tan x as t, then secant square x dx will be dt. So it will be 1 plus under root of t dt upon 2t. Am I correct? Now, half came outside. It will be 1 by t plus 1 upon under root t dt. Am I correct? Now, half came outside. This 1 by t integration will be ln t, and this is t to the power minus half. So its integration will be 2 under root t plus constant. Correct? Now replace t by 10x. It will be 1 by 2 ln 10x plus under root of 10x plus constant. So this was a simple start with a simple question of today's session. Got it? If you guys have understood it, you got it, like you may give your thumb impression, yes, we got it. You may give a thumbs up, give some reaction at least. It gives a boost to your teacher also. Well, now let's try this question. options are there. I am launching the poll also. So if you get the correct answer, please mark it in the poll. Yes, there it is. All right. Anybody else? Yes, yes. Quickly try, quickly, everybody. Use integration by parts to get through. Yes. See, that is enough. Now, let me try. See, how do we do it? The question is like I is integration e to the power sin x into x cos x. I split it into two integrations minus integration e to the power sin x into sec x tan x. The sin x upon cos square x is can be written as sec x tan x. Now we have two different integrants. So first of all, what I'm doing, I consider this e to the power sin x into cos x as second function and x as first function. So first function x, integration of second. Integration of e to the power sin x into cos x will be like this. Integration of e to the power sin x into cos x dx will be e to the power sin x itself, isn't it? Minus integration derivative of first one, integration of second e to the power sin x dx. That's it. Minus. Now take this one. I consider this one as first function, this one as second function. So first into integration of second. Integration of sec x into tan x is sec x. Minus integration derivative of first, that is e to the power sin x into cos x, integration of second, that is sec x dx. Am I correct? Now it is e to the power sin x into x minus integration e to the power sin x dx minus e to the power sin x into sec x, and plus this will be sec and cos will be 1. So this is also e to the power sin x dx. Now this e to the power sin x, e to the power sin x will cancel out. So you take e to the power sin x common, that is x minus sec x. So Delhi is the correct answer. And I can see 2 or 3 have marked Delhi as an answer. Got it? Well, now the two questions are there. They both are kind of having same concept. All right. First of all, you attempt question number 14. I'm launching a poll. You get couple of minutes to answer it. Yes, go through question number 14 first. Above one. Yes, yes, quickly. Everybody try. Very good. Yes, yes, quickly, quickly. Only three people answered as of now. Yes, give it a try. Be quick. Okay, can I have a word with the one student who have answered A as correct answer? May I know who is this? Who answered A as a correct answer? If you can, please raise your hand or unmute yourself. Yes, anybody who has marked A as correct answer? Or students who have marked C as a correct answer? Anyone? Four students have marked C as correct answer. Who are they? Okay. So nobody is ready to speak. No problem. I'll do it. Just a minute. See, now, if you remember, we have done a concept integration e to the power x fx plus f dash x dx. Its answer is e to the power x fx plus constant. I hope so many of you could remember this thing. Now the question is integration e to the power x tan inverse x minus plus 2x upon 1 plus x square whole square dx, correct? Yes. Now it is e to the power x tan inverse x plus I add 1 upon 1 plus x square to it. Then definitely I will also have to subtract it. And the another term is 1 plus x square whole square dx. Now this results into two parts e to the power x tan inverse x plus 1 upon 1 plus x square dx plus e to the power x minus 1 upon 1 plus x square plus 2x upon 1 plus x square chi square dx. Now see, let us assume this is your fx. then isn't it f dash x? So answer to this part will be e to the power x fx, that is tan inverse x plus. Now if I consider this as gx, this this will be its derivative, that is g dash x. So it is e to the power x gx minus 1 over 1 plus x square plus constant. So your answer is e to the power x tan inverse x minus 1 upon 1 plus x square plus constant. So the answer is Ahmedabad. E to the power x tan inverse x minus 1 upon 1 plus x square plus constant. Am I clear? Now, that was good. Now, everybody start with question number 15. Again, I'm launching the poll. Mark your answer correctly. Yes, question number 15. And this is an easy treat, undoubtedly. Yes, question number 15. Everybody, please give your best. What others are doing, keep trying. I only got response from 2 students. Okay. Well, now most of people have answered C as correct. Now let's see. If you remember, when I taught you the above form, I also gave you another form, that is integration fx plus x f dash x dx. And the answer to this form was x fx. I hope you all remember this. This is also in NCERT. Now the question we have, integration ln x upon 1 plus ln x whole square dx. Am I correct? Yes. Now see, I add 1 to it, subtract 1 to it. So if I split it, it is 1 plus ln x upon 1 plus ln x whole square minus 1 upon 1 plus ln x whole square dx. So that is 1 upon 1 plus ln x minus 1 upon 1 plus ln x whole square dx. I do one thing, I absorb this minus sign here. Now see, if your fx is 1 upon 1 plus ln x, then what will be your f dash x? F dash x will be minus 1 upon 1 plus ln x whole square into derivative of ln x, that is 1 by x. That means x f dash x is minus 1 upon 1 plus ln x whole square. So that means if this is your fx, this is your x f dash x. Am I correct? So answer will be x fx. So it is x upon 1 plus ln x plus constant. Got it? So x upon 1 plus ln x plus constant. C is correct answer. Congratulations to those who marked correct answer. Got it? Have a look at it, absorb it, then we'll go forward. Now, have a look at it. So you start with question number 18. Again, I give you a couple of minutes to think over it, and the poll is waiting for you to mark your answer. Yes, poll for question number 18, quickly. Calcutta, somebody mark. Let's see. What else? Somebody marked Bombay. Very good. Anybody else? Mark it quick. Be quick. Your participation is very low. Be aggressive. When you see a question, just jump over it. Take it as an opportunity. You are here to learn something, aren't you? Yes, be quick, be very quick. Only 3 students have participated in poll as of now. Be more responsive. Somebody marked A, very good. Anybody else? Quick, quick, quick. Very less participation. I don't know what you guys are doing. Like this, we are not learning anything. I want you guys to participate as much as you can. Now, see, the question is integration x raised to the power 4 minus x raised to the power 1 by 4 divided by x raised to the power 5 dx. See, first of all, what I do, take x raised to the power 4 common from the numerator. So, if you take x raised to the power 4 common from the bracket, you get x to the power 4 to the power 1 by 4 and 1 minus 1 upon x cube raised to the power 1 by 4 upon x to the power 5 dx. Am I correct? So with this you get 1 minus 1 upon x cube whole raised to the power 1 by 4 divided by x to the power 4 dx. This is what I got. Am I correct? Now let us assume this 1 minus 1 upon x cube is t. So 3 upon x to the power 4 dx will be dt. So 1 minus 1 by x cube, so it will be t to the power 1 by 4. Dx upon x to the power 4 will be dt by 3. So 1 by 3 outside, it will be t to the power 5 by 4 upon 5 by 4 plus constant. So answer will be 4 by 15. T is 1 minus 1 upon x cube raised to the power 5 by 4 plus constant. 4 by 15. So A is the correct answer, whoever marked it. Got it? Check it out once. Absorb it. Am I correct? Now, go with question number 19 quickly. Very good question it is. Yes, quickly. Well, if you have tried it, mark your answer in the poll. Question number 19. Delhi, I got one of the answers. All right, anybody else? Calcutta. Two students marked Calcutta. Well, I think I have given you enough time for this question. Now, let's see. The question is this. Integration of 2x plus 3 upon x plus 1, x plus 2, x plus 3 plus 1. So what do I see here? That it is 2x plus 3 in the numerator. If you multiply this x and this x plus 3, it is x square plus 3x. If you multiply these two, it is x square plus 3x plus 2 and this plus 1 separate. Am I correct? Now if you see this x square plus 3x, this x square plus 3x, it is common to both the factors and its derivative is there in the numerator. Yes or no? So if I take x square plus 3x as t, then 2x plus 3 into dx will be dt. So this will be integration dt upon t into t plus 2 plus 1. Got it? So it is dt upon t square plus 2t plus 1, that is dt upon t plus 1 whole square. So its answer will be minus 1 upon 1 plus t plus constant. That is minus 1 upon t is x square plus 3x plus 1 plus constant. See once. These are the kind of questions, if they come in exam, we should never miss them. Got it? So the answer to this one is Ahmedabad. Minus 1 upon x square plus 3x plus 1. Got it? Now, this question number 20 is a very, very good and important question. Give it a try. Integration of cosec x raised to the power p by 3 sec x raised to the power q by 3 dx. Given है p plus q is 12. So, what is the correct answer according to you? Quickly. Whenever you solve it, as such, it's a tough question. But see, you guys are there with an infinite potential. So if you solve it, just mark your answer in this poll. Somebody marked B, which has been very quick response. Very good. Anybody else? May I know who is this one who marked answer as B? Yes. Who is the student who marked B as correct answer? See, this is the problem. You guys don't interact at all. Two people marked B as correct answer. Very good. Others? Yes. Well, now let me explain it to you guys. See, the question is, one thing to notice here that this power sum is 12. Got it? Cosec x raised by p by 3, sec x raised to the power q by 3. See, the question is integration dx upon sin x raised to the power p by 3 cos x raised to the power q by 3. I took it in the denominator. All right. So now what do I do? Dx upon, in the denominator only, I multiply and divide by cos x raised to the power p by 3. So it became cos x raised to the power p plus q by 3. Because in the denominator only, I multiplied by cos x raised to the power p by 3. And now p plus q is 12, that is given to me. So it became dx upon tan x raised to the power p by 3 into, now it will become cos to the power 4x. If you replace p plus q as 12, it will be this. So this cos to the power 4 ko I take it in the numerator. I write it sec to the power 4, which is 1 plus tan square x into sec square x dx upon tan x raised to the power p by 3. Correct? Now let us take tan x as p. Then secant square x dx will be dt. So this is integration 1 plus t upon t to the power p by 3 dt. That can be written as t to the power minus p by 3 plus t to the power, this is t square, 2 minus p by 3 dt. So answer to this one will be t to the power 1 minus p by 3 upon 1 minus p by 3 plus t to the power 3 minus p by 3 upon 3 minus p by 3 plus constant. And your t is what? T is your 10x. So it is 10x to the power 1 minus p by 3 upon 1 minus p by 3 plus 10x raised to the power 3 minus p by 3 upon 3 minus p by 3 plus constant. So the answer will be 10x raised to the power 1 minus p by 3 upon 1 minus p by 3 plus 10x raised to the power 3 minus p by 3 upon 3 minus p upon 3. Very good. Very good to him who has answered Bombay as correct answer. Even I appreciate the efforts of those students who have given their full-fledged effort to the question. Yes. See it once, absorb it, then we'll go forward. Got it? Now, see the two questions are there. This first question, exactly like this question, even I don't remember, might be the same question, is there in the NCERT also. Miscellaneous exercise. And 23 is a very good question. Now, first of all, you attempt this question number 22. Go for it quickly. Question number 22. You get 2 minutes to solve it. Then we will launch a poll so that you can mark your answer. Yes. Question number 22. Now, I hope few of you must have got the correct answer. Mark your answer in this poll section. Yes, please. Three people responded quickly. More response I want. I discussed same kind of question earlier also. Yes. Others also participate. Well, now, let's see. The question is very good. Dx upon cos cube x cos x minus alpha. See, integration dx upon under root of cos cube x into cos x minus alpha. Now see, this can be written as dx upon under root of cos cube x. This one I can write cos x cos alpha plus Sin x sin alpha. Am I correct? Now this is integration dx upon inside the root. See, cos cube x is already here. Take one cos x outside this bracket. So if you took cos x outside, you get cos alpha plus tan x sin alpha. Am I correct? Now this total is what? Cos to the power 4x. You take out of the root, it will be cos square x. And if it jump to numerator, it will be secant square x dx upon inside the root cos alpha plus tan x plus tan x sin alpha. Got it? Now, see, tan x is there in the denominator and its derivative is there in the numerator. So let us assume this cos alpha plus tan x sin alpha as t square. I assumed t square because there is under root in the denominator. Correct? So it will be sin alpha into secant square x dx is 2t dt. So this became secant square x dx is 2t dt upon sin alpha into t. This tt cancel. So it is 2 upon sin alpha, integration of 1 will be t plus constant. So answer is 2 cosec alpha inside the root. It is cos alpha plus sin alpha tan x plus constant. See what a beautiful question it is. Have a look. Got it? So answer is Bombay. 2 cosec alpha, cos alpha plus tan x sin. Fine. Now, now you try this question number 23. Again, very good concept and very good question. Question number 23. Just give it a try. Then we will launch a poll to see how many of you have done it. Yes, give it a try quickly. Well, now I think you must have tried it. If you have done it, mark your answer in the poll section. There you go. Bombay, somebody mark. Others also please participate. Yes. Well, now let's see. See, one thing is very clear. This x minus 1 by x is something of our concern. Isn't it? Unknown caller. This x minus 1 by x is something we are looking for. Its derivative is 1 plus 1 by x square. Now see. See, this is the question. Now, if I take x square common from this bracket, numerator is x square plus 1 dx. Denominator is x square outside. It will be x square plus 1 by x square minus 1 cot inverse of x minus 1 by x. Am I correct? Now, subtract 1, add 1 into this bracket. Take this x square in the numerator, it will be 1 plus 1 by x square dx upon. Now, this will become x minus 1 by x whole square plus 1 into cot inverse of x minus 1 by x. Correct? Now if I take this cot inverse of x minus 1 by x whole as t. So its derivative will be minus 1 upon 1 plus x minus 1 by x whole square. Derivative of x minus 1 by x will be 1 plus 1 by x square dx as dt. So now you see this 1 plus 1 upon x square dx upon whatever there in the denominator, this whole quantity is dt upon t. Got it? Now its answer will be minus of ln t plus constant. So minus of ln cot inverse of x minus 1 by x plus constant. This is your answer. So this is minus of ln cot inverse x minus 1 by x plus constant. Such a good question it is. Have a look, absorb it, check it. Yes, be quick. Done? All right. One more question we'll try now. Now one simple question I'm going to give you. And I expect the correct answer from almost every one of you. And I want very good participation in this question. It is going to be very simple. See. So that's the question. Give it a try quickly. In a minute, I'll launch the poll. In the meantime, you get ready yourself with the answer. Yes, quickly, please. Now, poll time. Yes, mark your answer, please. I got only one participation as of now. What rest are doing quickly? Others also give your response. Anyways, this was a treat question. See, integration cos 2 theta can be written as cos square theta minus sin square theta upon cos theta plus sin theta whole square d theta. Now this numerator can be written as cos theta minus sin theta, cos theta plus sin theta. Cos theta plus sin theta will cancel. You will get cos theta minus sin theta upon cos theta plus sin theta d theta. Now if you realize derivative of denominator is there in the numerator. So answer is what? ln of denominator, that is cos theta plus sin theta plus constant. This was it. Very simple question. So now I would like to end this session here only. I hope I've been able to make you understand quite a few things. Do practice more. This chapter requires endless practice. The more you practice, you will be in a better stage. Now, just for a moment, I shall be asking for the class feedback. Please mark your